Assalamu alaikum. In this lecture,
We are going to talk about few methods by which we can improve the string efficiency. Now string efficiency, we already know that it is dependent on the value of k, and this k is actually equal to C1 is equal to kc. This is your shunt capacitance, this is your self capacitance. So k is equal to C1 over C. So C1 is your shunt capacitance and this is your self capacitance, right? So now if you have to reduce the value of k, what you have to do, you have to reduce the value of shunt capacitance. Now in order to reduce this value C1, what you can do, the insulator is attached with the tower through a cross arm, right? So if you will increase the length of the cross arm, the capacitance value C1 will reduce. So if C1 will be reduced, the value of k will be lesser, right? So what you have to do, you have to increase the length of the cross arm. So by increasing the length of the cross arm, the K value will be reduced and the voltage distribution across all the insulating disc will be more uniform. Now there is one limitation. If we are increasing the length of the cross arm, the tower should be strong enough to support the cross arm, right? So if we have to make stronger towers, then it will be more costly. So this is the only limitation if we have to use the longer cross arms. And in practice, usually we have the maximum value of k, which is equal to 0.1. So it cannot be more than 0.1. So this is the one method in which we can increase the string efficiency by using the longer cross arms. In the second method, we have graded insulators. For instance, in this example, we have 4 discs, 1, 2, 3, and 4. And what we do, we actually do the capacitance grading. And the capacitance of the disc that is closest to the conductor should be largest, right? Capacitance is larger, and the capacitance for the one that is closest to the grounded tower, capacitance is smaller. So why do we have to do that? We know that if the capacitance is increased, then Xc, which is the capacitive reactance, it will decrease, because Xc is actually equal to 1 over omega c. So if we are increasing capacitance, Xc will be reduced. So now if I have to find the voltage across the insulator which is closest to the conductor, the formula will be V is equal to I, which is passing through this particular insulator into Xc, right? So if Xc is a smaller value because of the large capacitance of that particular insulator, then the voltage will be a smaller value. So by using the capacitance grading, what we have done, we have increased the capacitance of this particular insulator, that in turn reduces the capacitive reactance, and finally, because of reduced capacitive reactance, we have smaller voltage across this particular insulator. So the voltage stress is reduced. The only limitation in this case we have is that we have to prepare discs of different sizes and having different capacitances, which is not feasible. So what we do, we usually have larger units which are closest to the conductor, and the remaining disc, all these 3 remaining discs have a standard size. So we only prepare one larger size disc that are closest to the conductor to reduce the voltage stress on that particular insulator. So this is the second method in which we have graded insulators. The last method for improving the string efficiency is using the guard ring. And in guard ring, what we have, it is a metal ring that is actually connected to the conductor and is surrounding the lower insulator that are closer to the conductor, right? So they are actually electrically connected to the conductor, and they introduces the capacitances C3 and C2 that are there to nullify the effect of C1, that are the shunt capacitances, right? So this shunt capacitance is actually equal to the line capacitance, right? So this is line capacitance, that is between the guard ring and the metal fitting of the string insulator, and then we have this shunt capacitance, right? So this is again between the metal fitting and the grounded tower. So what it actually do is that it just cancel out the current I1 that is flowing away from node A and B by adding the currents I1 dash and I2 dash. So the same current will be flowing through all the self capacitance discs, which are C, and the current that is moving away from the node A and B, this is your node A, this is your node B, it is provided by the line capacitances which are between the guard ring, which is connected to the conductor, and the metal fitting of the insulator disc. So by making the current through all the discs approximately equal, what we are doing is actually making the voltage distribution across all the discs uniform. So this is the third method for improving the string efficiency. We started from the brief introduction of the concepts of self and mutual capacitance. Then we talked about the shunt capacitance, which is between the metal fitting and the grounded tower. And after that we talked about the voltage distribution, and for that for the quantification of voltage distribution, we defined a term that is known as string efficiency that relates the voltage distribution among all the discs. And if string efficiency is larger, it means that the voltage is equally distributed among all the different discs. So the string efficiency is actually the ratio of voltage across the string and the multiplication of total number of discs with the voltage across the disc which is nearest to the conductor. Then after that we have derived the mathematical expression for the voltages V1, V2 and V3. What we have done, we have applied the KCL at node A as well as KCL at node B, and by summing the currents that are moving away from the node and making it equal to the current that are moving towards the node, what we have done, we have derived an equation which is V2 is equal to V1 into 1 plus K. Similarly, we have derived another equation which is for the voltage V3, and we found out that all the voltages, they are dependent on the value of a constant which is K, and this K is just relating the shunt capacitance with the self capacitance. Now if I have to increase the string efficiency of the string insulator, what we have to do, we either have to increase the cross arm length, and by increasing the cross arm length, what we are doing, we are reducing the shunt capacitance value, and if the shunt capacitance value is reduced, the value of K will be reduced, and if the value of K will be reduced, the voltage distribution across all the insulator will be equal. For the second method, what we have to do, we have to use graded insulators, in which we have the insulating disc having different capacitance values, and the one which is closest to the conductor has the highest capacitance. So if the capacitance value is larger, the capacitive lattice is smaller, and the voltage stress across this particular insulating disc will be smaller. So the only problem with this one was that we have to use the disc of different sizes, which is not feasible, or if you are able to do that, it is very costly. The last method for improving the string efficiency was using a guard ring, and this is a metal ring which is attached with the conductor, and it is just enveloping the insulator which are closest to the conductor. So the guard ring will introduce a line capacitance C2, which is just nullifying the effect of C1, which is the shunt capacitance. So whatever the current that is passing through the shunt capacitance is provided by the line capacitance, and the current that is passing through the self capacitances will be equal. So if the current that is passing through the string insulators will be equal, the voltage distribution will be equal, and if the voltage distribution will be equal, the string efficiency will be increased. So this was the today's lecture. In the next lecture, we are going to solve some examples related to the string efficiency, and after that we will be moving on towards the sag calculation of the conductor. Thank you.